Hi, everybody. Welcome back to Rockwell Process Consulting. And today I wanted to talk about a water facility that I worked with and some of the benefits that we got. It was a resin deionization regeneration plant. So this is all that they did. Uh, they would take the resin for filtering water, put that into giant vessels, and do bulk regeneration of all of the smaller tanks that they would get from their customers. And they had the best quality, the best length of use, capacity, and lowest cost of operation of their entire fleet of facilities across the country. This is a very large water treatment company. And we went in there and looked at what they were doing, uh, looked at the system, and found out that there was actually a tremendous amount of improvement they could be doing, even though they were the best. From a first principle standpoint, there was a lot of things that were able to be improved. So they had this great performance, but it wasn't consistent. They could do it 90% of the time, but 5 to 10% of the time, they would have a batch that would come out and wouldn't be meeting quality or would have low capacity, and they couldn't figure out why. And so, after looking into the system, we found a number of small pieces that were all contributing to this mystery that had been there for decades. So some of the things, we took the system apart, took it down, and inspected the vessels. We found that the injection nozzles were not uniform. They would break quite frequently, and the folks there would use the parts and pieces that they had to create new nozzles. So they were not all uniform. That was causing channeling within the resin as it was being injected. We also looked at the piping system going in. That was way too large, and that was causing channeling of the regeneration chemicals within the lines and then within the system. So not only the nozzles inside causing channeling, but also the concentrations of the chemical were not even across the bed. Uh, and so that caused them over time, as things would change and not go well, their natural instinct, because they were a low cost producer, cost is not an issue, they would continue to turn up the chemical. Since they were also able to get things done fairly quickly normally, they would also increase their rinse cycles. So they were able to get away with all this, but it changed slowly over time. It was this slow creep of more chemical, more rinse time, and decades later, they were very far off from what they should be ideally. And so after all this analysis, we made some small changes to the system, put in, make sure we had consistent nozzles. We changed the piping system around, which was a fairly inexpensive and fairly um, low time, low downtime project to get that changed. And we made that up in a matter of days after changing the operation. We got back online. Our consistency was 100%. We had very good consistency. The capacity of the resin was higher than it was prior, about 10% higher. And the quality of the resin output was even higher than it was prior to the changes. So we increased capacity and quality. We were also able to, after making all of these small to medium-sized changes in the system, we were able to cut the chemical by 3 to 4 times what they were doing. So they were overdosing by about triple or quadruple what the recommended, best practice concentrations were. So we were able to make an enormous impact on their cost of operation. The chemicals were actually a higher cost than their labor. So we impacted their number one cost, reduced that by a factor of 3 to 4. and then that became their number 2 cost at that point. So we had such a big impact there on what was going on inside the plant, and we changed some of the other operating parameters of how they were operating those, the timing, that then impacted waste treatment. So they were neutralizing all those chemicals that they were putting out into the waste treatment area. By reducing that by a factor of 3 to 4, they were able to make a follow-on reduction in their waste treatment area by about 75% reduction on the amount of chemicals that they needed out there. So overall, we cut the total chemical usage in the plant by about 60 to 70%, just by making some small adjustments within how the piping and basically those first principles, making sure things are right on the very basic levels, making sure those are right. We also made adjustments to the flow controls that they had. They were oversized for what they needed. So especially once we cut back on the chemical, the flow controls were way too large. They weren't able to control right off the bat very well what they needed. So we reduced the size again of the piping system to be adequate for what they were needing. And that gave them more fine control over the addition of the chemicals. And by not having such high concentrations of chemical, that in turn reduced the amount of rinse time that they needed to get all of the chemical out. We reduced the chemical hotspots by having a more uniform distribution and concentration of the chemical within the resin bed. And so all of these things added up to reduced water usage, reduced rinsing times. And so this is a sequential process. And so by being able to reduce the water usage, we actually shortened the batch time. So we were able to increase production by about 20% because of all those changes put together. So very large impact with pretty small changes to the system. But these are things that were sort of that slow creep over time. And these are the easy solutions to just turn things up. And so basically all of these things that we're talking about here can be applied to many different applications. It doesn't have to be water treatment. It doesn't have to be resin regeneration. The basic principles of correct piping size, mixing, concentrations, flow rates, all these things can be applied to any type of process to make improvements. So you just need to know what those are, and you can make huge improvements in your process with very minimal cost, time, and effort. So if you have any questions about that, or you'd like to ask me some more questions, please leave them in the comments or shoot me a message directly. And if you felt this was helpful, a like and a subscribe on the channel would be really appreciated. Let me know what else you'd like to learn about, and I'd be happy to do another case study video to address any questions that you might have. Thanks, and have a great day.